Here is a practice test problem for you on investigating horizontal transformation. The question is, identify the parent function f of x, write the equation of transform function g of x. How are the points in the two graphs related, right? And I'll add one more part to it, and that is to write domain and range of this function, okay? So let's add and just write domain and range of g of x, the transform function, correct? So we'll add this. Have a good look at the graph, copy it, and then answer it. Now once you have answered the question, look into my suggestions. You might get some tips here. So when you have a graph like this, first thing is just analyze. What do you notice? You notice a couple of things. One, reflection, right? So let's make a note of those points. So it is reflection on y-axis, right? That means inside function will change. Second, notice that after reflection it is kind of compressed horizontally, right? So it is compressed horizontally. And then you also notice that actually the graph position changed. It is not starting from origin, right? It is actually starting from -1. So it is 1 unit left. So this is what you notice. So this leads to transformation of your function. Which function is it? Which function is it? So that is our very first question. F of x is, it looks like a square root function. Now to be doubly sure about it, we say, well, f of x looks like square root function. Now to be sure about it, let's check some points. So we have these critical points which we know fall on square root function. Perfect points to test. So we have points which are 0, 0, 1, 1 and 4, 2. And 4 square root is 2, 1 square root is 1, 0 square root is 0. So that is just perfect. So we have tested that the equation is right. Why have I adopted this approach? Simply because when you write down your function for transfer function, I would like you to test that equation with points on the graph. That is the whole idea, right? You should make it a practice. After writing your answer, check your points, right? These are good points to check with on g of x, right? So this is how we approach, and then we see, well, how the points are getting transformed. So let's look into the kind of transformation. So let's imagine first it is only a reflection, because we have to do things in order. When you are talking about order, then reflection, compression, these are multiplication factors. They should be seen first and then translation. So think that 1 unit translation has not yet been done. Do you understand? So you said move 1 unit. So let's get back by 1 unit. So let's make another function. So let's get back by 1 unit and see what the function could have been if that 1 unit transformation was not there. So we get our function which was kind of like this. So 1 unit we just moving here. So we get a function like this. So let's move like this. That is my 1 unit function, right? So the function could have been like this. So if you see this function, then you will notice that each point, this is 1, but this point is half, right? This one is at 4, but this is coming at 2, the x value. So that means horizontally it is compressed by a factor of half. So you get your k value, which is 2, right? So therefore, you can write g of x now very clearly. That g of x is a reflection, which is minus. Second, horizontally compressed by a factor of half. That means k will be 2 times x, and you know it is 1 unit to left. 1 unit to left means x plus 1, and that is how you get your equation. This is probably the most efficient way of answering this question. Have a good look at it. Again, think about it, and then see whether it is really the best way of doing it. If it is, share your suggestions with me. That'd be good. and I want to improve on these videos so that I can provide you with the best answers, right? Anyone could have got this answer, right? Since it is the answer, right? The idea here is how to approach and how to get the answer in the best possible way. Correct? So we get our equation, and you see what? We did some reverse calculation. Now, as I was saying, check the points on gx. Now let's check the points on gx. If I plug in x value of -1, what do I get? So if I plug in -1, this becomes 0, and I do get 0, right? So it is -1, 0. Now let me put this point, which is -3. -3 plus 1 is -2. -2 times -2 is +4, and the square root of +4 is 2. So you get that point. So -3, 2 is correct. Since we have checked, we know these points are correct, we know our answer is correct, and therefore we write down our answer right there. And the answer for us is that function g of x is equals to square root of -2x plus 1, right? We've done this. Now, how are the points in two graphs related? So first and foremost, read all the questions, answer them all. Sometimes students will skip the last part, right? Now, how are the points related? That means related with respect to x. Since we compared and now we have the equation, we know the relation also. So we say, well, the relation is like this. Let me put the relation here. Let me put the relation here. So let us say this is f of x coordinate points, and on coordinate points our points are x and y. Then if we have the transfer function g of x, how do these points get transformed? We note one thing, that the y value is not changing, y remains as y. So put y there, at least 50% is right. Now for x, it gets reflected, that is minus times half of this, reverse, right? Then close the bracket, half of it, and then 1 unit left. So the x points are minus x by 2, half of this, and then -1, -1. So that becomes x value, right? Minus half, right? That is how it gets changed. So you do half of x and then take away 1. Since it moved, 1 unit left. That is how they are reflected. And then we come to the last part, and that is domain and range, right? So I'll write the domain and range in very short. Domain is, it is moving from -infinity to this point, which is -1. All are included. You can never include infinity. So you write -infinity, and this point is -1, -1, bracket close. This bracket shows that the point is included. As far as the range is concerned, it is greater than 0, which you could also write as greater than 0 means 0 is included, right? And plus infinity, which you can never include. So that is another way of writing your domain and range, right? So that completes the question for us, and I hope you understand all the aspects of horizontal transformation with this particular example. Remember, whenever you are doing transformations, you have to follow a sequence. All these multiplications should be done first and then the translations. Otherwise, you may get a wrong answer. What I'm trying to say is 1 unit left and then reflection. If you make this first move as like this, 1 unit left, your graph will be kind of like this, right? And then if you reflect, then your graph will be like that, which will be a wrong answer. Do you see that? That will be a mistake. So be sure that you do your work correctly. Okay? Now, I hope with that we end this set of questions on horizontal transformations. And if you have any questions, do write to me. My email address is given, and I'll share your suggestions. How was your experience going through this? Thank you.